Hello guys, today I'm showing you an alternative way to draw a parabola. You have already learned how to sketch a quadratic function while solving inequations or while drawing a parabola in analytic geometry using points, vertex and symmetry axes. Now I'll show you something else. We know that y equal to a times x squared plus b times x plus c, where a, b, c are real numbers, is a quadratic function, and its graph has always the shape of a parabola. This parabola could pass through the origin, the point O, 0, 0, but not always. That could be elongated or flattened, thin or fat, turned upside down. Its concavity could be upward or downward, and the shape moved up or down, left or right. So in order to draw well a parabola, we have to calculate some points, and this isn't a simple or a quick method. There is no quick method for plotting a quadratic function. We always have to remember three things to draw approximately a parabola. The meaning of coefficient a. If a is greater than 0, the concavity is upward. If it's less than 0, the concavity is downward. Second, the formulas for calculating the coordinates of the vertex v. Minus b over 2 times a, and minus delta over 4 times a, where delta is squared b minus 4 times a times c. Third, how to calculate the intersections with the coordinate axis for finding the intersection with the x-axis and y-axis. And when the parabola doesn't intersect the x-axis, you have to find other points. The better is near the vertex, which is at the bottom or at the top of the parabola. But what happens if you don't remember how to find the coordinates of the vertex, the formulas for the vertex, or the parabola doesn't intersect the x-axis? The delta of the equation is minus 0, or the calculations are difficult, like these two examples, where delta for the first is 9 minus 4 times 2 times 2, negative 7, or in the second, where delta is 15 minus 4 times 2 times 1, like 17. Negative 7 is a negative number and is not possible to find intersection. 17 isn't a perfect squared number. It isn't fast to calculate them. So let's try with an example this alternative way. Y equal to x squared minus 3x plus 2. The key sequence is Check the coefficient a of x squared to find the concavity of the parabola. Second, make a system between our parabola and the straight line y equals c. For our parabola, y equals 2. The solutions are very easy because the known term 2 of the equation is simplified, and at the end we find the 2 points that belong to the parabola. Like this. x1 equals 0 and x2 equals 3 over 2. Third, the most important step and the last step is finding the midpoint between x1 and x2. So we can obtain the x-coordinate of the vertex that for symmetry must stay in the middle on the symmetry axis. The midpoint is the sum of the two terms over 2, 3 over 4. And then substitute 3 over 4 in the equation of the parabola, we find the coordinate, the second coordinate of the vertex. Let's watch with GeoGebra. We draw the straight line, find the intersection between the quadratic function and the straight line A and B, find the x-coordinate of the vertex with the midpoint, substitute it in the function, and with the 3 points in the plane, draw approximately the curve. Well, that's all. But at the end, I wanted to show a little trick to calculate other points for a more accurate curve. Suppose that you have the same function and have a number like x equal 5. If you apply the function, you have to take several steps. The square, multiply 2, take 5 another time, multiply it for 3, and then make the two sums between the already founded terms and the constant 2. Let's read this equality that I have written in this manner and put 5 in the x. Open bracket, 5 multiply 2 minus 3, close bracket, multiply 5 plus 2. If you think a moment, you can calculate the result with just one step. This way, you can minimize the number of calculations. Easy, isn't it? Well, now that's really all. I hope that's all clear, but if you have some doubts, please play back the video and draw some function on your own, like this. Tomorrow, during the next lesson, you could ask to me. Enjoy your study and see you soon. Bye bye.